Well, first of all, we should learn that the time in the air for ball number 1 is equal to time in the air for ball number 2. So that is really important. Later on when we start doing problems and examples, that concept is extremely important. So the time in the air for any projectile, no matter what happens to it, only depends upon the vertical velocity and the vertical forces. Also, we should always keep in mind that the motion in the x direction, so we're talking about the horizontal direction, is completely, and I mean completely, independent of the motion in the y direction. Of course, that would be the vertical motion. So why did I take the time to write that down? Well, it's a really important concept. So in all problems I'm going to do with projectile motion, you can look at the horizontal motion and the vertical motion completely independent, as they have nothing to do with each other. The only thing is that the time in the air depends upon how long it takes for the object to hit the ground in a vertical direction. So let's now talk about how we describe the equations of motion in the 2 dimensions. So for the horizontal, since there are no forces acting on in that direction, there's no gravity in the horizontal direction, we can simply say that the velocity in the x direction is simply equal to the initial velocity in the x direction, and it doesn't change. So whatever the initial velocity was in the x direction, it will maintain that velocity throughout its entire motion. Doesn't change. Notice that the arrow in the horizontal direction doesn't change. That represents velocity in the x direction. The distance traveled in the x direction is simply equal to the initial velocity in the x direction times the amount of time that the object stays in the air, which is determined by the vertical motion only. All right? On the vertical motion, the velocity in the y direction is equal to the initial velocity in the y direction plus the acceleration times time. And in this case, we can probably just say that the acceleration for a projectile will be, of course, the acceleration due to gravity, and that's a minus 9.8 meters per second squared. Notice that if it has no initial velocity in the y direction, then v sub y is simply equal to g times t. And for the position, we could say that y is equal to the initial position in the y direction plus v initial in the y direction times time plus 1/2 gt squared. And of course, that came from the equations of motion. So those are the 2 ways in which we look at motion of a projectile, horizontally and vertically, and we keep them completely separate. So there's a nice little introduction of how to look at 2-dimensional motion and how we look at x and y motion completely independent. And that's the basis by which we're going to solve all problems for projectile motion. We always start out with the concept, how long will that projectile stay in the air? And so the question becomes t in the air. And the equation we use for that is y equals y sub naught plus v sub naught in the y direction times time plus 1/2 gt squared. Typically, we find the time in the air first, and that's the equation we then need to find that. So again, final height when it hits the ground is 0, initial height when it starts at 50, but now it does have initial velocity in the y direction. Before we can figure out what that is, we need to find the components of the initial velocity. So we need to find the initial velocity in the x direction. Oh, I say x and write y. That's nice. So in the x direction, and we need to find the initial velocity component in the y direction. Of course, in the x direction, it'll be the initial velocity times the cosine of the angle theta. And here this will be initial velocity times the sine of the angle theta. So the only difference between this problem and the previous problem, where the object was shot horizontally, we now also have some initial velocity in the y direction, so we get a little bit more complicated quadratic equation to solve before we find time in the air. And that's how you do this problem.